So we're looking at inequalities on a number line. So first of all, write the title down, put the date. Then if we look at question 1a, we all know that 5 add 3 is equal to 8. And in this situation, using the equal sign is the best because the left side does equal to what's on the right. However, what if this was the situation? We had 5 add 4 on the left hand side, and on the right hand side we had 8. Now we know 5 add 4 is not equal to 8. That's why this topic is called inequalities. 5 add 4 is more than 8. So how do we write this? We would use this sign here. This sign here means the left side is not equal to the right side. It means the left side is greater than the right hand side. Or 5 add 4, which is 9, is greater than 8. So I like to think of it as a diagram like this, where we have an equal sign, and then can you see this is getting wider here until you get into this situation. Okay, so it's like the equal sign has been squeezed on the right hand side, and this is the smaller bit and this is the larger bit. So the larger side, the larger numbers on the left hand side and the smaller numbers on the right hand side in this example. This diagram might help you to remember how the inequality sign work. So as you can see in this one, obviously the elephant is much larger than the mouse, so the inequality sign is shown in this way. And in the bottom diagram, obviously on the larger, the elephant is on the right hand side and the mouse is on the left. So hopefully this diagram will help you to remember. So question 1b, as you can see on the left hand side we have 5 add 3, and on the right hand side we've got 9, so we've got to put a sign in between. So we know that 5 add 3 is 8, and this is less, so we're going to use this sign. 5 add 3 is less than 9. We can't use this sign because the left side is smaller. So here are some more examples. As you can see, 7 is smaller than 9, so that's why the sign's been shown like this. 2 is smaller than 4, so we've got the sign arranged like that. 6 is smaller than 12, and 3 is smaller than 6. And as you can see here, -6 is greater than -12. Okay, so -6 is a bigger number than -12. I could also write 12 is greater than 4. I could write 100 is greater than 1. So I hope these examples show you how to use the inequality sign. Okay, so now I have a number line, and on the number line I have to show where x is equal to 2. So that's quite easy. X is equal to 2, I can just show like this. So this circle shows where x is equal to 2. But what if the question was show where x is greater than 2? Well, again, x is 2 is here, and all the numbers greater than 2, they're in this direction, and that's how we show it. So this shows x is greater than 2. Now notice that I have an option here to either have an empty circle like this or have a colored circle like this. I would deliberately have not colored this one in. As you can see, it's like this. It's left open, unshaded. That's because when we say x is greater than 2, it means x cannot be 2. It has to be a number more than 2. So the smallest number it could be, or in the question they might say, what is the smallest integer? Integer means whole number. So the smallest integer that fulfills this criteria would be the number 3. If this was shaded like this, if I shaded this in, then that would mean x could be 2 or more. That would mean if it was shaded, it would be x can be 2 or more. But in this situation, the question didn't say that. So on this number line, I've represented x is greater than 2. So for example, if you go on a ride in a theme park, they might say the child has to be more than 2 years old. So a 2-year-old child cannot get on this ride. The youngest the child can be to get on this ride is 3 years old. Or in the question, if they asked you what is the smallest integer or the smallest whole number, then you write 3. Right. What if they said x is less than 2? So this sign here now means x has to be less than 2. So I've written it in words here. X is less than 2. So again, 2 is here. And these are all the numbers that are less than 2 in this direction. Notice that I have not done this. I have not shaded this in. Because the question says x is less than 2. It didn't say x is equal to 2. So sometimes in the exam question they might use this word integer. All that means is a whole number in this case. So if they said, so what is the largest number or integer? That's what the word integer means. So what is the largest number that fulfills this rule or this criteria? So the word integer means whole number. So x has to be less than 2. So it has to be the number 1 or less. Okay, you cannot have 2. So for example, if they said in a, I don't know, a nursery, okay, or a play center or something, that children under the age of 2 can play in this area, it means a 2-year-old child cannot play in this area. The child's age has to be less than 2. So the oldest the child can be is 1 year old or 1 year old. So the word integer means whole number. What about if we were to show where x is greater or equal to 2? So again, 2 is here and the numbers greater than 2 are in this direction. But it says here with this sign is equal. So x is equal to or greater than 2. So this sign here means equals to or greater than 2. So it's the greater than sign with the line underneath it. So because of that, we have to shade this in like this. A shaded in means it is equal to 2 and more. So if the right said a child must be 2 years or more, it can be 2 years or more, then we shaded it in. If it said just greater than 2, then we cannot shade it in. So to represent when x is equal to or greater than 2, we would shade in where it says 2 and then draw the arrow to show where x is greater than 2. If we were to show where x is equal to or less than 2, so this sign here now means x is equal or less than 2. Well, equal to 2, because it's equal to 2, we're going to shade it in, and less than 2, we would show the arrow like this. So this now means x can be equal to or less than 2. If however I left it open like this and did that, then that means x is less than 2. It's not 2 or less, it's less than 2. So here the So here the largest the integer can be is 2. The largest the integer can be is 2. And here the largest integer could be 1 because the circle is not shaded. So here the largest the integer could be is 1 when the circle is left open. So this means the number is 1 or less, okay, because it's not shaded in. And here, because it is shaded in, it means the number is 2 or less. Okay, so what do you do in a situation where they might say that in a play center children must be between the ages of 2 and 5? So in this case, notice that x is greater than 2 but it's less than 5. So what are the integers? What are the whole numbers that fulfill this criteria? So x has to be greater than 2. So the smallest number is 3, and the biggest number that it can be is, it has to be less than 5. So the biggest number or the biggest integer it could be is 4. So that is it, is 3 and 4. These are only two numbers that fulfill this criteria, where x is greater than 2. X cannot be 2, so it has to be greater than 2. So the first whole number that's greater than 2 is 3, and x has to be less than 5. So it can't be 5, so the one less than that is 4. So that means only children who are between the age of, who are 3 years old and 4 years old can play in this area. Okay, if they're 2 years old, they're too young. If they're 5 years old, they're too old. So how do you show this on a number line? So 2 is there and 5 is there. Now because they didn't use this sign, say 2 is equal to or less than x, we are not going to shade this in. It's going to stay open because they've used this sign. Same with 5. Where is 5? They haven't got a line underneath the sign, so therefore that will stay open as well. And because it's between 2 and 5, we just draw a line like this. So that means x is between 2 and 5. So more than 2 and less than 5. We will not shade this in. If we shade this in, it means 2 is included and 5 is included. So now in this example, in this play center, the rule must be children can be 2 years or more, so it's equal to 2 or more, but it is 5 or less. So the children's age can be 2 or more and 5 or less. So what are the integers that fulfill this criteria? So they can be 2 years old, they can be 3 years old, they can be 4 years old, and they can be 5 years old. So those are the integers that fulfill the criteria. So this time, where is 2? 2 is here. Where is 5? 5 is here. And because it's got this line underneath, okay, means equal to, we're going to shade it in. Same with the 5, it has this sign underneath, okay, so it means it's equal to, and because it's between 2 and 5, we just join like that. Should be a straight line. Okay, so that shows that x can be 2 or more and x can be 5 or less. But what about this situation? In this situation, for 2h, x is equal to 2 or more but less than 5. So the integers that fulfill this rule, x is equal to 2, that's fine, or more than 2, so it can be 2, 3 and 4, but it cannot be 5 because it said but less than 5. It didn't say equal to and less than 5, it said less than 5. So in this play center, children who are 2 years old, 3 years old and 4 years old can play. Or they might say children who are 2 or more but less than 5, and this will be represented like this. So 2 or more but less than 5. So because it's 2 or more, we can shade the 2 bit in, but because it's less than 5, the 5 has to be left open, because less than 5, it's not equal to 5. They didn't say equal to 5. Can you see with 5 we had this sign. We did not have the equals sign with it. So this is what it looked like. So this diagram now represents where x is 2 or more but less than 5, and these are the integers that fulfill the criteria: 2, 3 and 4. I'll give you one final example. So in this situation, it's saying that x is greater than 2. Notice it didn't say x is equal to 2, x is greater than 2, but it is equal to 5 or less. It is 5 or less. It is equal to 5 or less. So in this play center, for example, the rule might be the children have to be 2 years old, but they can be 5 or less. So the integers that fulfill the criteria are 3, 4 and 5. The whole numbers that fulfill the criteria. You cannot have 2. So because x is greater than 2, sorry, we're going to have an open circle at 2, but because it's equal to or less than 5, we will have a closed circle at 5, and then we'll just join it with a straight line. So this means x is more than 2 but equal to 5 or less, and these are the integers that fulfill that criteria. So this is the inequality. This is the diagram on the number line that represents the inequality, and these are the integers that fulfill the criteria of the inequality. So I would like to try question 3 on your own first, and then we'll go through the answers together in a bit. So question 3, A, B, C, D and E. There's 5 questions that I'd like to try. I'll make it a bit bigger. So it says here, write down the inequality that is represented by each diagram. So what is the inequality that's represented by each diagram?